Good morning to one and all present here. We will be starting this session now. Welcome back to this 5-day faculty development program on architectural design pedagogy for engaging studio experiences. We had some really great lectures yesterday. Both the lectures that happened yesterday were very interactive, very engaging, fruitful discussions where some new avenues of thoughts were opened. Today also we are looking forward to some enriching lectures by our two expert speakers. The first speaker of the day is Dr. Shankar Pratim Bhattacharya. Sir is an associate professor at Department of Architecture and Regional Planning, IIT Kharagpur. Sir's area and research areas and areas of expertise include thermal comfort and building energy modeling, vulnerability and disaster risk assessment, construction management, and many others. Sir is also the principal investigator for many government-funded research projects. Today, Sir will be taking a lecture on exploring high-rise building design and services. So we welcome you with open hearts. Thank you for accepting our invitation and taking time out for us from your hectic schedule. Thank you so much for being with us, sir.
Okay, thank you.
Sir,
Yeah,
yes, sir.
thank you very much for introducing me, and also thank you for inviting me in this MDP. And I'm really great to see the people joining from different corners of the country to and enhance their architectural education, which is necessary because time passes and different type of technology, different type of design philosophy are evolving. So this is high time even for us also to upgrade ourselves from other co-colleagues and all. So I welcome all the participants on behalf of me and behalf of the organizer. So my as Professor Mishra told that my lecture will be on the high-rise building and the services. So it is actually some of my understanding of the high-rise building uh, in a particular course which we usually conduct as elective course for BF people or in the IIT KGP. We float that course maybe 5 years back, and it was very, very popular. It's the elective course, but it's very popular among the students. So I was partially handling that course, and another professor, Dr. Shumana Gupta, she was also handling the same course. So yeah, my part is the services part, and so I will actually jot down some of the points where a architect has played a vital role while designing the floor plates. So may I start my presentation?
Yes, sir. Sure.
Okay.
I just have a request for all the participants. Please put your cameras on if possible for you all. And we will also be taking a few questions from the audience, either in between or at the end of the presentation, as per what Sir wants. So please be ready with your questions. If you have any questions to ask, you can also write in the chat box, or you can also interact in the end of this FDP. So we are expecting active participation of you all in this lecture. Thank you. Sir, please take over.
Is the screen visible? My first slide of my PPT.
Yes, sir, we can see it.
Okay. So the topic is exploring high-rise building design and services. It's challenging really to actually come down to design and services and understanding that in a very short period of time. But I know I am actually delivering lecture to the audience where there are most of the learned people, faculties, and the architects are there. So basic understanding is definitely they have, and based on that, I have designed this particular lecture. See what happened in the down in the line of maybe 150 years back. It was a dream to construct a high-rise building. Why it is a dream? Because in that time, just after the or before the industrial revolution, if I say around 150 years back, it is only possible to construct 4 to 6 story building because there are three constraints. One is the too many steps to climb and down. Number two was the masonry wall thickness was too high at the base, because as you know, it is a, that time it was all the load bearing kind of a structural systems. And the last one is the framing could go, so in case of the high, it will be become very unstable because of the high wind pressure. So if I these three things if we target, and then that was a really challenge to them, but thanks to the industrial revolutions which was happened 150 years back almost, and then these two gentlemen was actually initiate the process. The first one is the Bismarck process, which was invented in almost about 1855, which actually induced the industrialization of the production of the steel, which is from pig iron. And you know, the steel is a better material from the structural stability point of view. So we can think of something like a RCC or maybe the steel structure, which now can go a little bit high without compromising the thickness at the ground level. The next one is the Otis, the Elisa Otis, very similar time, 1857. Actually, he invented the brake shoe of the lift. Lift was already invented, and he actually started a company called the Otis Elevator, which is still alive. And now the elevator is in practice, and this elevator actually get rid of the climbing up and all those kind of problems. And as the steel came, and there are different better material, better type of glass also came in the as a byproduct of the industrial revolution. The framing of the glasses as the highest level or the high level also won't be a problem. So these two small or maybe two invention actually ignite the possibility of the high-rise building, and by virtue of that 1885, maybe around 30 years down the line, the first so-called first high-rise building came in Chicago, which was 10-storied building only, 42-meter height. The building name was the Home Insurance Building. This building is no more. It was demolished, and demolished, and the other high-rise building was constructed. But this building was actually a load-bearing kind of a structure. And if you see the photograph, the right-hand side is having the very high amount of fenestration and thick walls and all. Fenestration, amount of fenestration is very high, because that actually reduces the dead load of the particular building. So it's somehow first high-rise building was constructed in the North America, and then thereafter one and another building came up. Now, if you see the total history of this down the line, this gentleman, Fazlur Rahman Khan, who was a Bangladeshi, born in Dhaka and is American afterwards. I mean, went to America after his graduation, midway of his graduation, and did structural engineering from there. And he is recognized as a father of modern skyscrapers. And then in the 70s, where there is a boom in the high-rise buildings in the USA, he was actually the developed the concept of the structural concept, which was the fundamental concept of the high-rise building structure. Fazlur Rahman Khan, F.R. Khan. This is a kind of the postal ticket which Bangladesh government has the developed on his name. So what he told, if you see the high-rise building, and if you in the x-axis, if you just increase the height of the building, so generally there are two type of load, as you all know. One is the gravity load, because of the each floor is adding some amount of load, because of the wall, because of the floor, because of the floor finish, because of some kind of the live load and all. And if you go high, there is additional lateral load, which is like wind or seismic load will also imply to that. And to encounter this to load, actually, we put lot of amount of steel, a lot of amount of material, structural material, right? So we have to increase the thickness of the column, we have to increase the thickness of the bracing, foundation also is going to change. So if you see the height of the building, if it is increased, the steel, structural steel required for the to take care of the gravity load is actually increased in linear manner. So if you increase by 2 floors, whatever is increasing, you have to increase another 2 floors, the same amount. But it is not true in case of the lateral load. It exponentially increases after certain height, and actually it will actually take care of the, it will take the first bench out of these two. And Fazlur Rahman Khan is called the excess amount of the additional steel required to take care of the lateral load is called the premium for height. You have to give some premium because you are going high. So with this particular concept, we let us start our discussion. And all we know, we can now at present we have three type of the high-rise building or the tall building or the skyscrapers are actually divided into three categories. Tall building is almost about 50 to 300 meter. 300 to 600 meter is called the super tall building. So the if you see in worldwide data, so almost 90% buildings are tall, 50 to 300, 10% buildings are of super tall in nature, 300 to 600, and mega tall building is more than 600 meter or so. So it is very few, maybe 0.05% are there. So this is some of the visual classification or the of these three type of super tall, mega tall, and the tall building. So what happened is that in the past 120 years or so, there was an array of modification, there are array of inventions, and there are array of influencing factor which actually uh, uh, boosted us or actually are responsible for growth of the tall building. Particularly we have developed a lot of new material, we have developed a lot of technology, the number one point which I have written. The regulatory change in the civil bodies also give us some boosting to think for the high-rise building. The change of the demography in the urban areas, yes, we need a lot of buildings in the urban areas. Urban areas are actually spreading out. So the center core, the city core areas are now very much, land price is very high. So definitely the character of the building is also going to change. The modern economic and the commercial impact to the society is also going to impact on that. The per capita income is increasing. The per capita income is very high in the urban areas also. So that is the another cost people can afford. The other points which are very important, that is the software technology development. The recent advancement of the software technology, particularly designing, modeling, detailing, and the management also. So for that, I mean, tall building design is not a joke. I mean, it's not like a cannot hand compute and all these things cannot be done. You need minimum some the reasonable kind of the software to develop that one. Then you have to actually go to some kind of simulation models or for wind load and other things. So that are now available. So you can have a lot of the exercise, and then you can go for the best one, which is performing best also. Now let us go to the my part, that is the services principles. How we are going to think. See, the one of the major point is the design of a tall building is it is a group work. A conceptual development can be generated in the architect's office, but it has to be actually vetted through the structural counterpart and also the services counterpart. And then again, a rethinking and the re-evaluation is needed. So there is this kind of cycle is going on for few more times, and then the particular building can come up. That is the first very important point. It is not like the other building, like you are designing a museum or you are designing a shopping mall or maybe a housing. So there, particularly in the phase of design, architect takes a very lead role. Here also architect will take a lead role, but he has to actually go to their counterpart very frequently, not at the fag end of their design. If the design is germinated, then only they should have a kind of a first discussion like that. So in the list, what the services we have to actually see are the water supply, sanitary, solid waste, electrical services, illumination, fire services, acoustics, may not be that much of prominent acoustics, but still we need to see that one, because at the the height, height, there may be some of the issues. Vertical transportation is the one of the biggest challenge in the high-rise building. Network services is the modern things, HVAC, building security, and the access control. So those are the list of things we have to actually see that these services should take care of as per the code and also as per the requirement. And the challenges are, I mean, the factor considered for the application of the building project, that what are the other type of challenges will we actually will to encounter is the technology. First of all, whether that technology is available. Suppose I'm thinking of some kind of fire service, which I have probably seen in Dubai, but is it available in Calcutta? Is it available in Chennai? So if you think of that, we have to see the function of the each and of services. We may change our function and character of a building, the application in the building, the specification and the efficiency of the each and every component, the operation and maintenance of the particular system, and of course the cost of installation and the operation. So out of this particular constraint or this particular periphery, we have to decide the best choice, and we sometimes we have to take the second best, or maybe some other options also, because sometimes it may not be available, or maybe it is very costly, or maybe the operation and maintenance also very high. So that way we have to see. There are some other environmental issues also. We are in a tropical country, we have a high rainfall, we have we are a very dusty country, we have a lot of dust and in the atmosphere. So those are the things we have to decide about the operation and maintenance part also. So when we see the different component of a floor plate, so first of all we'll design the floor plate, a particular plate that may be circular, square, elliptical, whatever it may be. But that floor plate will actually consist of these three parts. One is the activity space, that means my office, my apartment, or maybe some kind of the space which I have dedicated for some kind of activity. Then there is definitely some circulation space, corridors, and some kind of circulation corridors and the connectivity from the different part of the building, different part of the activity space, which consume almost about 60 to 70% of the space. And a 30 to 40% percent of the space will be consumed by the core. The core is actually the active area where I will actually put all my services in the in the high-rise building. Core is probably not very much well scattered, which actually we see any kind of the horizontal spread building. In the horizontal spread building, we have maybe two such staircases in the fag end of two part, and maybe there is actually the entrance staircase in the middle. So it may not be that much spread out. So it will be actually in a very close territory. Now in the core, we will actually try to put the lift, we put fire stair, we put toilets, AHUs, air handling units, electrical, security, and the network control room. And we have to have put, because those are required some kind of a vertical transmission. So we need some kind of the wet duct, and where some kind of a dry duct also. The wet duct are actually take care of my sanitary and the water supply pipelines, whereas the dry duct can take my HVAC, electrical, and network cable. So like that, we have to design. Now, if you see this core, all the items, you have to first of all have to find out the how much area will be dedicated for the each item. Lift, suppose, then we need to have the what is the occupancy, what is the height of the total height of the building, what will be the speed of the lift you are designing for, and what will be the cycle time. So like that, we have to actually see the what is the waiting time and all. Then we may go for the 3 lift or maybe 6 lift, 8 lift, something like that. And then we know the dimension of a lift, so we can find out that how much area is required. Similarly, fire staircase is also governed by the bylaws. Number of toilets is also governed by the bylaws. AHU will be governed by the some of the character of the how much thermal, or sorry, the cooling load is there, is required. So from that we can have some kind of a idea. maybe the the security and the network rooms may not have any kind of bylaws, but a tentative dimension has to be fixed for them because it is something like a room and there are some instruments, cable and all these things has to be housed. And by virtue of all those arrangement, we can find out what should be the size of the wet and the dry duct by virtue of some understanding or maybe some virtue of some my past experience. Now, you see this is a floor plate that what I'm talking about. Out of that, these are the core and the activity space. And that was definitely the activity space was connected through the core by the circulation space. So this will be the tentative kind of the share of the areas. So look like this particular building has of course almost about 40% core and 60% of the maybe like the activity areas also. So we have to first understand this and then we have to jump into the activity space area, how much will be the area and how much will be the core. Because I know my plot area, I know my FAR, so I know how much square foot or the square meter area I can build, and I know how many floors I want or whatever, and then from that it's a totally a kind of a calculation, and then I will deduct the amount of core which is necessary for a high-rise building, and then I will left out with the activity areas also, and then I will start thinking of the shape and all other things. Next is I will prefer to first design the core of the high-rise building because that is very much governed by because as I understand that FAR gives me the total height, and from that I take 60% of the activity areas is my activity area, office space or hotel space or maybe the apartment or maybe some kind of a shopping area, business area or whatever. And then I know that from the guidebooks and all those that what will be the total population. So from that I can understand that what will be the number of lift, what in per floor, how many occupant will be there, so how many toilets will be there. So like that I can actually can design. So I can make some kind of a dotted line grids, and by virtue of that I can place something. Yes, this can be my lift, core and other things, and then I can decide that yes, this is my T stands for toilet space, S stands for services area. I may give some kind of the electrical room, HVAC rooms and all these. L stands for the lift, and FS stands for the fire staircase and all, and there are some passages and all, and then I can decide that yes, these are the dry duct and the wet duct will be there, and that will the wet duct definitely will be very near to the toilet. The dry duct will be definitely in between the service spaces like electrical service and the HVACs and other network service and all. So like that, we first design it, and we should comply that space and the number of lift and all those by some kind of the logical understanding and some calculations and all, and then we will start thinking of going some kind of the design of the activity areas and the circulation area. In the general layout of the circulation area, sorry, this is suppose the core area, just demarcated a red area as the core and the services and the lift. Yeah, the blue one is the wet duct and the yellow one is the dry duct. And then I need some kind of a circulation area, so that I have shown in the green. And then I have some kind of the outer area because that is my maximum floor plate as per my FAR that is recommended also. So this is the activity area. And then I may need some more circulation space because I want to make it four different part for four different offices or maybe something like that. So like that gradually I will go. So I'll go like this. I'll just go like this. I'll design this one. I know this much of the circulation corridor is required. Then this I will get it from my FAR calculations and all. And then I need this kind of the circulation. Sometimes maybe in some floor I may not need this thing. Maybe I can get rid of this two. Only this two will be there. Okay, fine, because this is a too large office or whatever. Okay, like that I can now change accordingly. So, so like that, I can have. single pole, single kind of a thing. I may have double core systems if I want to have kind of a rectangular kind of a thing. So there are general layout is now possible. Now this way, gradually I can develop. So in our in our course, we used to give the student something like, after teaching this much of portion, we give some kind of a small class exercise like that. You have given a plot and you are uh, suppose this is the office building or something like that, and this is the affair, and you need to go this much amount of high, maximum height is this, and then what should be your concept of your core, and how much is your the activity area, and how you put the things staggered, how. So this can invade we have around 3 to 4 hours in a particular we sometimes dedicate it a weekend, and then we start giving them some kind of a small exercise. And we also supply them some NBC, where from they can actually find out how much is the toilet area, how much is the lift area is required for cater to some kind of the population and the occupancy per floor also. So this can be a very small exercise we can design, and then we can evaluate them. Then how much is the understanding of the general floor layout also. Next is the vertical layout of the high-rise building core or a duct system. So suppose if I say this is a particular core, a floor plate. See, the blue on one is the wet duct, and red ones are the central lift duct, lift core, and the dry ducts are yellow, and green was is the corridor, and the yellow one is the activity area. I have not bifurcated the activity area. Can you tell me which type of building is this? Just to look into this particular distribution. Can anyone tell me which type of building probably is this? Which type of activity, not building, sorry, activity is in going to happen in this floor? Wet ducts are not centralized, it is distributed along with the corridor. That is the clue, hint.
So we have two responses in the chat. First one is hospitality
Yes,
by Neeta Mishra ma'am, and the second one
yes,
is hotels by Kritika
yes,
ma'am.
both are correct. Yes, it is very simple. It is both are correct. It is actually hotel or the hospitality kind of a scenario. We have different suite on different rooms along with the corridor, and we should have the wet corridor throughout. So it is hotels, and this is where something is inside, which way of talking in the last slide also. The wet cores are inside. Probably may not be a very good design, but still it can be functional. So then what is the kind of the building or the space? Definitely not residential, because residential will something look like the hotels only, but the distribution may be in different part, may not be exactly located of the along with the corridor. So the second case may be of the offices, because of course I have told you it may not be very good design that every time I coming out from my office and go to the central core, and I will go to the toilet, washroom or so, but still it is sometimes maybe effective. So now the problem is, if I go to the next slide, I'll find a problem. So if this is the hotels, my section of the building will look like this. You see the blue ducts are at the end, fag end. And suppose there are some, it is a mixed used building, and there are some offices also. So in case of the offices, the blue ducts are inside, not at the fag end. Right? Conceptually, I can say there is a lateral shift of the kind of the duct, the port and the blue duct. And now if I have the high rise, upper floors are of the hotel, and the lower floors of the offices. So the ducts are blue ducts or something like this. So the upper 5, 6, 7, 10 floors are the hotels. So the ducts will be perimeter duct, and the offices are the central duct. So something like this. Or it may happen because of your change of the some character of the high rise. If it is a mixed use kind of a thing. So how to do this? We have to actually introduce a gap between them, and then you take the duct by virtue of some kind of a horizontal movement and then connect it to the central one. The perimeter will connect it to the central one, or sometimes the reverse. The perimeter may be connected to the peripheral one. Or sorry, the central one can be connected to the peripheral one. And this is called the service floor. We need to have some kind of a service floor is required in this particular case like that. Even though suppose you have all 40 floors are offices or all 40 floors are of your hotels, but still you require in regular interval after 15 floor or after 10 floor, 15 to 20 floor, maximum 20 floor, it's a service floor is required. Because pumping the water from the ground level to the 40th level is not that easy. So you have to pump in different service floor, and the different service floor will be give discharge to the gravity to the lower floor. That is number one. Number two, suppose you think of a wastewater pipeline and you just flush your toilet from the 40th floor, and the water will passes from 40th floor to the ground floor. You can you imagine how much will be the pressure of the water? It will going to burst at the ground level because of the gravity. It is actually down, actually coming 40 floor height, 40 into 3 or 3.5, almost about 120 plus meters. So what will be the velocity of the water at the ground floor? Very high, and because of it will be going to thrust and it will be going to break. So you need to actually take the water 15 floor, 20 floor, and then having a kind of a chamber which will take the particular thing a horizontal way movement. Velocity will be down, and then again it will flow, overflowing things like that. Like that, we have to step down the things and go on. Similarly, in the service floor, we can house the air conditioning systems also dedicated for a particular batch of floors. So like that, we can think of a service floor in between. So service floor is required. Now there are different type of zoning, vertical zoning. This particular zoning is required for the duct, maybe the wet duct, the distribution cell. The dry duct, there won't be a problem as such. But if the dry duct is shifted because of your alignment changes for office and hotels or whatever, or apartment and office and all, or maybe the apartment and hotel, again you need a service floor to change this thing. In case of a lift, it can be of different type of zones. You can divide is a small height or the regular 10 floor, 15 floor building. You can have a single zone. In case the building is more than that, you can have two zones of the lift, because the one particular lift will take too much of time to go climb to the level of 40 floors or so. But in case of the tall building, we may have a multiple zones. So multiple zones are there, just like we take express train to go to somewhere and then take a local train to go to nearby village. So something like that, we can take an express lift to go to the 20th floor and take a local lift and go to the 23rd floor. Something like that can be arranged. So there is a non-stop 0 to 20 or something like that, and from 20 to 40 there are two such non-stop lift. And if you want to go to the 26th floor, you take 0 to 20 express lift, and from the 20 to 26 by a local lift. So in this case, there is a kind of a sky lobby is kind of a dedicated lobby, which is actually interchange lobby. That the change of local lift, sorry, the express lift to the local lift is dedicated. That particular zone is called the sky lobby. So sky lobby is also important. If your building is so high and if you are designing a lift, first definitely we'll try with a two zone or single zone kind of a scenario. Sometimes it fails because of the waiting time and the occupancy load. So it is too much of the cycle time. So we have to break it. So we then break it in different zones, and then we try. There will be some 2, 3 the alternative cases, and then we can take the best one. So this is the sky lobby. So what we understand from earlier slide, it was the service floor and the sky lobby. Then we need to have some kind of a vertical interfacing of the structural grid of the building also. Suppose this is a kind of a upper floor structural grid. So upper floor, suppose it is the wind is very high. So I have to little bit of packed, densely packed kind of a scenario has to be followed. So I have a little bit the in regular interval there are columns and all those have been placed. But in the lower floor I may not require. I may have a large banquet halls or maybe the some auditoriums or something like that, large offices or so. So my structural grid will be different. Maybe the thickness of the column may increase, but there is not so much of the not so much of the footprints. So then again the same problem occur. So there are so many columns in some the group of the floors, and in the lower floor there are only two. So here also we need a particular floor where those columns or structural footprints are actually uh, transmit the overall dead load or whatever the load to the next layer by some kind of a deck, by some kind of a girder to the next layer, and this particular intermediate floor has to be constant, and then this is called a transfer flow because it is transferring the different type of loading pattern to the different type of loading pattern ups and down through a particular girder also. So this is eventually required in our tall building design because I know it is mostly tall buildings are the mixed use building. It has different type of structural footprint requirement and we have to take care of that. We cannot take the all structural footprint thoroughly from the top to bottom. So you need transfer flow. But yes, a sky lobby and transfer floor can be the same. By definition, they are different. A service floor and a transfer floor may be the same. No issue because anyway, I can have the typical kind of the height requirement and I can have that in the transfer floor, the depth of the beam will be little high, but in between two beams, that area I can use for any kind of the service requirement, the horizontal bend of pipe or some water stations, water pump and the HU units and all. That I can use. But by definition, it is different, but I can actually, both can be clubbed together. So that is why I required a frequent interaction with my structural uh, associate and maybe with my services associate to design the things. So there are some of the definitions which I have just now discussed. The service floor, it is provided in some regular intervals or in some kind of interface in the activity spaces to accommodate the smooth flow of the service duct. The sky lobby are the interchange points where people can change from express elevator to the local elevator or so. The transfer slab is also the kind of a float systems which support the vertical as well as the lateral load balancing system to two different structural grid. And also there is another floor is called the refuse floor. It is a floor which is dedicated, there is a dedicated area for any kind of the emergency gathering, particularly in time of fire. So in case of fire, so people can rush down. As you all know that in case of the fire, I have to take the staircase, fire staircase. But it is not possible to me, for me to actually run down from 40th floor to ground floor at a time. So I may come down to 40th floor to 35th floor or maybe some 32nd floor. And that floor is a refuge floor. I have some kind of evacuation gathering space or so where which is fireproof and all those. Right. So it is also required. So these are the four such spaces and there may be some kind of the permutation combinations possible. So now if you see the core configuration and the tenant distribution, so this will be something look like that. You can have a central core, which I have discussed earlier. We can have a split core, which is the two part of the building, which we can have a end core, which is only one end of the building, which is very efficient because you can have whole area can be actually used for your rental space. And we may have a atrium kind of a core where there is a central atrium and the core are actually in the atrium. And you can have a single tenant, you can have a double tenant A and B, we can have a multiple tenant A, B, C, D. So like that, you can make different type of groups, and you can different the arrangement of the that your circulation space can be also arranged. Next is the effectiveness of the different type of core configuration. Suppose you have put a core in the edge, core in the central point, it is a detached core. So from the core, there is a bridge kind of a thing, and it is every floor there is a bridge. So there will be a two cores in system. There will be a four corner kind of a thing. There may be a random kind of a scenario. So in this case, there are some kind of the factors which I have noted down from a paper. The whether the flexibility of the typical rental areas, perimeter of the rental areas. So those are the typical points. The ground floor high rent areas, the distance travel, and all those. So the excellent, poor, and fair and average grading also can be done. So we can actually discuss that one with our students, and then they can actually see that which particular core system they may go from the structural benefit also, and from the their benefit from the designing, the architectural designing of the spaces also. So suppose they go for the corner one. So then probably the perimeter rental areas are kind of a poor in that sense, or maybe the core expansion at the ground floor is also very poor. So that way they can go for any kind of the particular choose. They can choose any type of the configuration for their design. So these are the some of the examples of the core and the activity areas for some very popular high-rise buildings. So mostly core are actually centrally placed, and they the perimeter wise the things are provided. There is an advantage if I go with a central core. It will actually give a lot of shear wall, and the shear wall is actually act as a backbone of the particular structural systems. So now let us discuss with some of the structural systems of the tall building, because you know the structural systems is another important point which may not come under the services, but it will decide your total configuration and the services systems also, because you sometimes need a typical type of structure, the shear wall, or maybe some kind of the other type of systems which is mandatory to provide, where there can be a conflict between your the service core and the structural system. So as we all know, the building is actually going to have the dead live and some kind of wind or the lateral load, or maybe some kind of the earthquake. So wind and earthquake we called as the lateral, and dead and live we called as the gravity load. So from the structural point of view, what we have to see, if we see it's a tall building, it's like a pendulum, right? It's like a pendulum, or it can be act as a cantilever beam which is supported at the ground, something like that. So we have to need to know the how much is the lateral sway, lateral the induced vibration. Both you know that the wind and the earthquake is kind of a time dependent load, so it is going to have the vibration. So you have to see the how much is the bending, how much is swing. So we may not actually know that one because we are not structural engineers, but we need to actually discuss in depth with our counterpart to know that what type of structural system he or she is going to adopt. And from that, I need to see my activity areas and my core areas. Then there will be definitely a story drift. Definitely, we cannot avoid that one. Even if you go for a rigid material, it will be some kind of the elastic things will be there in any material. So that part, it will be have some kind of a shift. And then there are a lot of forces will be induced and all. So then the strain, stress, all these things will be there. So now we have to see the member stiffness. We have to ensure that each beam and column should have a stiffness. If the the floor stiffness or the storage stiffness you have to see. It is not now the member, you have to see the overall stiffness of the story. So you may introduce some kind of a bracing to increase the stiffness of the overall story, because bracing will be connected from one beam to the other beam, so one floor. So sometimes one way bracing will be enough, sometimes no, you may have to go to two-way bracings kind of a thing in the periphery perimeter. Then sometimes we need to go for more type of bracing with the belt truss. So you can have some kind of a belt in different part, vertical part of the building. Then in the tall building, we have to see the 5 basic structural element. One is the grid system, what we are going to have. Then this bracing system, what I have discussed. Then we need to have some kind of a the strategic location shear wall that will give boost me the total the flexibility, sorry, the stiffness of the building, and the taking care of all the kind of the lateral load. We have to see the load transfer mechanism also, that we have already discussed. Then you have to see the what will be the my foundation system, what will be the, is it a raft only, it is a pile, or it is a raft and pile, or sometimes do you have to do some kind of a soil improvement technique and then go for foundation. So that has to be also discussed. Then we need to know the vibration of the building because of the earthquake or the any kind of the wind. We need to have some kind of a dynamic oscillator systems also will be there. So it can be a tuned mass damper or the liquid mass damper, which can be placed at the top of the rooftop or the top floors. Sometimes we may go for some kind of energy dissipation devices in each bracing systems also, or that can be of the frictional damper or the metallic damper or the viscoelastic damper, or sometimes we may actually go for some kind of a base isolation. So we can isolate the building from the foundation. So definitely this particular isolation is better adapted in the seismic areas, not for the wind, but this too, the energy dissipation devices and the dynamic oscillator are better suited for both the seismic and the wind activities. So based on these fundamentals, we can divide the whole system of in two types: the interior system and the exterior system. Of the interior system, we have rigid frames, vertical strass also. So it is having two type of system: exterior and the interior. Why it is called interior? Because the major part of the lateral system is actually inside the building, and the exterior major part is the outside. So it's creating a kind of a box, or sometimes we may go with a hybrid. So this is the interior kind of a system where there are the systems are imparted in the interior of the building, and these are the exterior system where there are the tubular kind of a system which is emerging out from the exterior. So this 1970 onwards, this tubular system was developed by the Fazlur Rahman Khan, and it has as a greater benefit from the load bearing or load resisting point of view. The next, let us go to the fundamentals of the MEP design. The MEP is a Chalu language in case of the high-rise building services. M stands for mechanical, which is mostly HVAC and the fire and all, fire extinguisher. E stands for electrical, and P stands for plumbing, mechanical, electrical, and plumbing design. So as you see, there is a water supply network. If you understand the kind of thing, so we actually get the water from the service mains, and we need to take it to the fire tank first, and then the overflow of the fire tank goes to our storage tank, which may be underground. And then we can have a booster pump also, which actually take care of my underground water. Sometimes I may not have sufficient supply from the mains, so I need to have my own water booster water from the underground, and then I have to take it to the overhead tank, and then from the distribution pipelines. So this is the nature. This is the total. It will be look like in a high-rise building in the basement or some of the other area. You need to have this kind of booster pump to boost the water from some level. Maybe you can have to get it from the underground, or sometimes you have to have sufficient water in your underground storage tank, and from there you can have to boost it to the different layer, different floors. So as we can think that how to design it. National Building Code Volume 2 gives fundamentals of the requirement, or you can go to IS 1172 for the basic requirement of the water supply and the sanitary, etc. So we need number of people, population, building type of the water connection, community, and all those, availability of flushing system, and we can decide the what will be the total consumption of the for water and total requirement of the water. And then we distribute in the various service zones, and we put different capacity of tank in the different service zones. So we have to know about the pipes, joinery, valve, all the accessories. Mostly it will be done by our consultant, but we need to also see through, because sometimes it may have you may have some kind of issues. We may have some kind of the past experience which may gives you some kind of a bad efficiency or those kind of issues. So we can actually discuss that. So those are the some of the materials and the remarks I have noted down, and nominal pipe sizes which recommended by the codes. So from the boundary, as you know, it's take to the ferrule, and then it is going through the water meter, then the underground tank, then it will be through the pump, it will go to the rising main, and then the overhead tank, and from the overhead tank it will go to the supply. This is a very simplistic manner. We can think of a G+5 building or so, but this will be repeated in the nature in the high-rise building, and this is the typical layout of the overhead tank, so that you can skip. So this will be the typical nature of the overhead, I mean the high-rise building, where we have T1 and T2, two different dedicated the tanks for the different zones. T1 and T2 will be placed in the service floor, and then there are underground tank to the 10 floors and 10 floors. So we can find out the what will be the T1 capacity, T2 capacity, and all. And we can also find out the power requirement, how much horsepower of the pump I will purchase for that also in this equation. Next is the air conditioning system, where we have to actually go with the comfort temperature, then the relative humidity, air qualities, and all, which is one of the essential system for our high-rise building, and also it will consume lot of energy. Almost 30 to 40% of the energy will be consumed by the air conditioning system. So we need to know what is my set point temperature. So we'll design how much is the total cooling load. So for that we need to know the what will be the humidity level, standard humidity level will maintain, and then what air quality of course doesn't come with that, but still we have to see that what will be the fresh air exchange rate to maintain some kind of the good air quality, and the air movement distribution patterns or so that also we have to be checked. So from that point of view, I can discuss with my consultant, HVAC consultant, and what type of system they are providing, that we have to know. Now in case of the HVAC system, this is very important. There are few issues that always we encounter, even for the horizontal spread building also. That what is the total air conditioning load? So always we need to see that this particular air conditioning load is one of the governing factor to take the decision of which type of system I am going to purchase or design for my building. Then next one is the design of the building. How is my floor plate designed? Right? If it is, what is the total spread of the floor plate? So I know that my the dry duct is located somewhere in the central position. So from there, I have to circulate the whole air conditioned, the treated air to different locations. What is the remote location, and how much is the pressure drop? Okay, theoretically we can place, okay, no problem, but there will be a pressure drop. And due to the pressure drop, there will be no that much of ventilation, and the air exchange will not be proper. So there may be some kind of the discomfort. Then what is the proximity to the surrounding buildings? So that is also important, because we have to take decision that it will be create some kind of the heat effect outside the buildings also. The height, visibility of the equipment. See, sometimes it is very bad looking that all the air conditioning systems is exposed outside and it is visible from the outside. So how to take care of that? So we have, in time of design, you have to place some kind of a terrace area, and we have to actually somehow hide that particular part with some kind of a ornamentations or something like that. Initial capital cost, definitely one of the biggest issue. Life cycle assessment of the cost, and also the total aesthetics, because as I told in the fourth point, which has to be also take care of that. So in a holistic manner, we need to see that the what systems can be taken. So now if you see the type of air conditioning system, the first two are very basic that we usually put in our residential building or in our institutional areas, but these two are not going to have not going to work in the tall building. Split and air conditioned kind of a thing is very uneconomical and not at all efficient in this kind of a high-rise buildings also. We cannot think of a window air conditioner and the split air conditioner in the shopping malls, right? Because why? It is a huge amount of load, cooling load. So it will be very much uneconomical, and also it will be not so good. Efficiency also will not be good. So you have to think of some kind of a distributed system. In case of a distributed system, large scale cases, we go for the distributed system. We have air cooling systems also, or sometimes we may go with the refrigerant or the water cooling system also. This is very interesting. So air cooling system is a little bit old fashioned, where we actually have two type of things: constant air volume system or the variable air volume system. This is nothing, it is just the constant air volume is the every duct will take the same amount of the air, same amount of, in the sense the same rate of air exchange. And whereas depending upon the need, we can have some kind of a regulator and we can have some VAV type of system. But finally, at the end of the day, this air cooling system is the, we are cooling the air and sending the cool air to different part of the building. Whereas in the second system is the water or the refrigerant system, where not the air, but the refrigerant or water is chilled, and then chilled water or the chilled refrigerant is actually sending to the different part of the building, and air is actually flowing in and around that particular that heat exchanger and then get cooled, and then the total area is going to be the cooling of the total area, or the total the air has to be done. So this is called the VRF system, the variable refrigerant flow system. So let us see the air cooling system, how it is done, which is very traditional. So we have a cooling tower, we have a chiller plant, we have some cooling coil, bulbs, etc., etc. So definitely this is a part of the instruments or the some kind of a thing which is actually housed outside. So we take intake water, that intake sorry, not water, air, and that will be chilled thoroughly, and then that will be sent to different air handling units in the different part of the high-rise building, different floors. And then from the AHU, a supply air duct will take the cool air to different room, and we may have some kind of, when it is entering to a different room, we may put VAV damper. What is VAV? Variable air volume, that kind of a damper which you can regulate, and that take care of the that particular temperature or that particular flow rate. And after this, we should have a return air duct which will take the little bit warm air after circulation throughout the room, and little bit warm and humid, of course. The return air, there is a return air fan that will draft the air, force the air directly to come inside in that intake air area, and then this total services or total process will be recycled. So when we take the next layer, next cycle, so maybe the 30% of the return air and the 70% of the fresh air can be mixed together, and then we will follow the system. So this is the typical nature. The centralized air conditioning plant is huge. The VAV system is a small kind of the instrument which has to be hanged properly in the duct, and that can have some kind of a monitor regulator or so, which can your adjust your amount of volume flow of the air. and the AHU units which will be placed in the different floors. That actually there is a pump, and that will going to circulate the different type of different part of the building. Now, what are kind of the refrigerant systems? So we have a chilled water, where the unit where from the chilled water or the refrigerant will come to the building, which I have shown in the blue lines, and this will go to the fan coil unit on each locality. Those there will be not that much huge duct because the volume of the air is too high. So, and the volume of the water will be less, so it will be a pipeline. So those pipes will be connected to the FCU, fan coil unit. The fan coil unit will look like our split air conditioner, and in the from the room, the hot air will actually suck into that particular fan coil unit, and it will actually go through the this coil, which is the chilled water is passing through, and the treated cool air will come out. Like this process, this particular room will be cooled after you switch on the particular fan coil unit. And then a return water or the return refrigerant will go from that fan coil unit, which is I have shown in red because it is a little bit warm. And then again it will go to the chilled unit, and then it is again going to be chilled and then again supply. So the water will pass through, or a refrigerant will pass through, not the air. Air is actually just the inside room air is going to be exchanged, the heat exchange will be take place. So for a large scale building where there is a huge spread out from the AHU or from the central point, the air handling, sorry, the air cooling system will fail, because you need to have a huge amount of the duct sizes, and that will take up a lot of areas, also lot of the headrooms and all those. So because of that, it is better to think of this kind of the refrigerant system kind of a thing. So a rooftop unit can be handle a particular building. So this kind of rooftop unit can be placed in the service floors or the refuge areas, or maybe the transfer floors or so at the dedicated point. And this particular can one or two or three depending upon your total amount of cooling load. And this can be actually placed in the different part near to the dry duct, and you can take the refrigerant and all for the dedicated those bunch of floors. The last one is the electric supply. So the electric supply is multi-storied building is little different with respect to the other type of building. Actually, we get the electricity, or we can generate also electricity in our site by virtue of some kind of the DG set or so, or we can purchase the electricity from the local electrical utility company. So from the LEUC, we can have the generator also, that we can have transformer, we can have that kind of the power backup system, and we can have some kind of internal distribution system. So we need a main electrical switch room or control room which houses the switch panel, because sometimes in there is some problem in our country, sometimes there may be some problem of electricity. So my generator or that particular the system will feed me. So this two feed system, the one is from the power houses, that is the state power authority, and also from my own generation, that switching systems can be there. Nowadays there can be a third arrow also in this particular point. That is the green energy, that maybe we can have some kind of solar panel, so we can actually take that one also in our the mains control panel. So this is the primary feeder which comes to the transformer, which takes to the main electrical switchboard, which houses lot of circuits breaker, electrical meter, etc. Then this will go to the distribution board, and this distribution board, as you know, it is divided into floor wise, divided into zone wise, and divided into load wise. Floor wise, we understand each floor should have at least one. Now zone And each floor, depending upon your distribution of the floor, suppose you have 4 tenant area, you have 2 tenant area. So you have multiple zones. So one dedicated for the floor and one each for the zones. After that, the load. In each zones, there may be different type of loading. There may be electrical lights, there may be electrical machines like computer and all other things. There may be other type of things like some kind of air conditioner or some kind of a machines, and other type of machines, maybe some kind of small equipment or so. So based on that, there are different load, and we can again in each zone there can be further bifurcations depending upon the load. So, and then from the distribution box, it will go to the different appliances, and the branch circuits are also will be there. So this is a general kind of the understanding now. My electrical consultant will tell me that in each floor, where is the suitable location for the distribution box, if it is if he or she is planning in a zone wise or so. Sometimes that particular distribution box is placed in a very odd area. Suppose I want to, it is just at the entrance, or maybe at the your visual sight lines, it is some kind of distribution box. And I've seen people actually hiding that distribution box with some paintings or something like that. Okay, and this is not good. Distribution box should be actually always accessible because of some kind of emergency. We are hiding with some painting or something like that because it is somehow placed in a particular location where it is actually striking in the view line or so. So we have to discuss that one. That how much is the load and how much is the zones, and I'll let them decide. They are the best person to decide. But I should know actually what is they are going to place it. Sometimes it will spoil you a lot of. There are some of the times the door and the position of the door and this distribution box is again going to make some kind of a conflicting kind. We have to change the door locations also because you need that much amount of wall area to house the distribution box, and then you have to lift some of the brickwork or some machinery work, and then the door. So you have to change the door position. The door position changes, you have to change the layout and all. So that need to discuss with the thoroughly. It is mandatory for the not only for the tall building, any type of building. So these are the transformer, that is the main switch board that houses your the electricity from the supply people, and also from your own generations and all. Distribution box. This is the network. The tray, the cable tray. It will be look like. You have to think this also in case of the any building design. This much of the cable will actually go, and this will be really looking very odd if it is not placed properly. So this is the electrical control room look like, and these are the systems. As you all know, it has electric meter. It will have some kind of MCB, RCDs, and MCCBs, and all those. We have a lot of electrical load points, appliances, fan, computer, pump, machines, etc. You have some control unit like switchboard, ceiling rows, etc., and you have some kind of cable and duct. So if you see, this is the very the schematic diagram where I have shown a electric meter, a MCCB, it is miniature circuit breaker, where from it has to be a sum total of all the loads has to be taken into it, and then it will go to the MCBs in different floors, and then it will be connected. So in case of the high-rise building, we will go with this. So each floor we have the two-pole MCB or maybe the RCD, and then this MCB bank and neutral link. So this they will going to design. But if you see it is complex, and if you just want to see the number of sub-circuits depending upon the total distribution of the load, the number of cable you required to channelize from MCB bank to the different part of the building is you need to think, because otherwise you have to place some amount of area, some dedicated area in the corridor and whatever. Of course, in the above the little level or so, where actually you can accommodate those kind of a extra amount of pipelines horizontal for horizontal spreading. And also you need to have the cable for the network cable, the Wi-Fi cables and all those kind of thing. Or maybe you need to have some kind of other type of power cables for some building security or some other CCTV cameras and all. Those cables are also there. Telephone lines are nowadays not very common, but at least network lines you need to be there. So LAN connections and all. And you also think of the running pipeline, horizontal pipeline for the air conditioner, that the chilled water also, and that also has to be wrapped with the thermocol or those kind of the insulator. So it is pipe and then there are thermocols also. So those are the things. So there are some of the point we need to know. You have to know the layout of the apartment building or any building. You need to know the activity plan, furniture layout, electrical gadgets. So like that we have to decide. So these are the some of one of the floors will look like. So they will give you the calculations like that, how many, what will be the installation of the MCBs and whatever, as per the ampere rating and all. So this is the whole, this is not our job, this they will do. But we need to oversee that should not foul with our all other counterpart, some AC counterpart or the network counterpart. So we need to have kind of periodic discussions and all. So like that, it will go to the other floors. This is for the ground floor, suppose. So as I told you, ground floor has in this particular figure 1, 2, 3, 4 zones, which is marked as 16 ampere 2 pole MCB. So that is a 4 zones. Suppose I have divided ground floor into 4 zones. I may divide the first floor into 5 zones or 3 zones, depending upon my need. So like that, each floors in a particular zone, ground floor has 4 zones, and from each zone there are 1, 2, 3, 4, 5 MCBs of different rating. Okay, 3 ampere, 2, there are 2 6 ampere, there are 1 10 ampere. Definitely 10 ampere will be linked with some heavy duty machines. Okay, and the 3 ampere, those are maybe linked with the lighting systems. 6 ampere and all may be linked with the computers and all those kind of things. So like that, there are these circuits and the sub circuits and all these things will be there. So you can imagine that how what will be the tray size, what will be the total amount of the number of cables and all after each zone. Through zones, maybe it is single or 2, 3 pipes, but after that, each zones will be really large. So this is the electrical service room look like, the power distribution cable and the feeder plug, light control rooms, etc. that we can go through. Those are some of the references, and thank you very much. And I am now open to the questions. Let me check with the.
Thank you, sir. Thank you so much. That was a very detailed presentation. You touched so many different points related to high-rise building and services as well. Everything was very detailed, very clear, and you explained it in a manner that it was understandable to each and everyone. Thank you so much. So can we take some questions?
Yes, 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 sure.
Participants, if you have any questions or anything to say, the floor is now open. Any questions by anyone? Okay, as we do not see any queries or questions, I think we come to the end of this lecture. So it was a great session, truly. So I just have one request. Can we get this presentation that you
Yes,
shared?
I will email you today itself.
Okay, okay.
Okay,
Thank
I
you
will
so much,
fill
sir. Thank you.
it. See
So it was
this.
a great presentation. We really got to learn a lot. It was very concise and very clear, detailed, and in one of the best possible ways, you tried to explain high-rise building services to us. Thank you so much for your precious time that you have given us today, and that too on such a short notice. Thank you so much, sir.
Okay, I will send you this presentation by evening, today evening.
Sure, sir.
Okay, I'll email you.
Okay.
Thank you very much, participants and the organizer for inviting me. It is a great time with you. Okay, thank you very much.
Thank you, sir. It was always a great pleasure learning from you.
Thank you. Karan. Okay,
Thank you, sir.
okay. See
Thank
you.
you, sir. Good day. Okay. Participants, we will have a short break now. The next session starts at 2:30 sharp. So I request you all to please join back by 2:20 maximum. A lot of you joined late in the first session. Please try to be on time in the coming session. The next session will be by Pradnya ma'am. It will be a continuation of yesterday's lecture, and today she will be giving us some assignments as well that we need to do and submit in the last day of this FDP. So please be present on time. Try to not miss anything because this second lecture will be very crucial. Um, I hope you all will be present as attendance in all 10 lectures is also mandatory for receiving your certificate. So I'll see you after this half an hour break. Let us all meet by 2:20.
Yes, ma'am.
Okay, thank you. We will be starting very shortly, just waiting for the expert lecturer to join.
So, how was the meeting today? Morning meeting?
It was great, ma'am. Am I audible properly?
Yeah. Yeah.
Okay, yeah. Ma'am, it was taken by Dr. Shankar Pratim Bhattacharya from IIT Kharagpur.
Yeah.
He took a lecture on high-rise building and services, and it was great. It was very detailed. He talked
Morning.
about high-rise building design, about different types of services, and explained it in such a detailed manner, easy to understand
Yeah.
and great. So it was good.
Very nice.
I request all participants to please welcome our expert speaker, Professor Pradnya Chauhan, ma'am. Ma'am has already taken a lecture with all of us yesterday. Still, I'll just shortly give a brief of what happened yesterday and what will be happening in today's session. Ma'am is an academician and author. She has recently written a book known as Learning Basic Design. Ma'am is also offering a 10% discount to all the participants of this faculty development program for her book. I have already shared her contact number in the group. You can contact her to avail this offer and to receive your copy of this book. In yesterday's lecture, ma'am opened different thought processes and different avenues of basic design to all of us. Um, Today's session will be all about explaining different activities, and at the end of this session, assignments will also be assigned to all the participants. I'll leave the details to ma'am, what is going to happen and how are we going to do it. But ma'am, we are all really looking forward to this session. We're all excited to learn what all the different activities are and what will be our part in this. So I hand over the mic to you, ma'am. You
Okay.
can begin.
Yeah. Okay.
Someone has written a message saying they are unable to join in the WhatsApp group. I would like to highlight this to all the participants that a WhatsApp group has been formed for all participants. The joining link for this WhatsApp group is in your mail, in your confirmation mail. I'm sharing it again in the chat box right now. You can pick the WhatsApp link from here as well and you can join this group. Make sure that you join here because all details related to your assignments, your feedback form, and your certificate will be circulated through this WhatsApp group itself. Please be a part of this group.
Yeah, shall I start?
Yes, ma'am, please.
Okay, so this is the book cover page. So like to start always with my cover page of the book. This is the book which is priced at 1400 rupees, and I'm ready to give you a discount of 10% for the people who are attending this workshop. So today I'm going to talk about all the basic design exercises that we have done so far in Rizvi College of Architecture and also in other colleges. So here are the exercises. After end of these exercises, I'm going to give you share the exercises which I have designed for you. Actually, then we are going to share this entire PowerPoint of exercises with all of you so that you can choose what you would like to work on. And by tonight, you should give the confirmation to Nishtha as to which exercise you would like to take up. And I would suggest that not more than 5 people take up one exercise. The moment you have more than 5 people, then Nishtha will tell you, no, ma'am, will you, sir, will you choose another exercise because this exercise is already chosen by five people. And these exercises are pretty simple. The idea is for you to make these exercises so that you can give it to the students. That is the whole idea. So the idea is, yes, you, I want you to do that, but I want you to understand the potential of the exercise and give it to the students so that they can exercise their creativity and so on. So today now I'm sharing the PowerPoint which I have prepared for the basic design exercises. So this is an exercise which is called creating maze with lines. So aims and objectives, I'm not going to go through the whole thing because otherwise it's going to take hours and hours. So this was a very simple exercise where we assembled all the students from the entire college, from entire class, and we made them into made a line of ascending order in terms of height. Then we divided this entire height into two groups. So the first group gathers in the center and makes formations, while the second group creates a circle around them and sketches out the formations. The students standing in the circle create various formations like a straight line as seen in plan, or curved line in plan, or sometimes curved line in elevation. So I make the students stand up, and then somebody's crouching and somebody's sitting, and then you create a wave amongst the students, and students who are outside, they draw these. So there are a number of sketches and number of drawings which the students make. After this is done, then they come back to the class, and then they start drawing these sketches and doing the models using matchsticks, and they stick these matchsticks on thermocol, and then they weave the paper, colored paper depicting a maze. So students make minimum 3 models for the maze, and then there is a discussion at the end of 3 stages, and to achieve the understanding of versatility and strength of the line and dot. So there are lines and dots, so understanding of lines and dots. So at every stage of the review, the models are displayed on the platform to discuss the merits of this project. We give a crit based on the elements and read them. We talk about density, rarefication, and color schemes. So this is how the students were assembled, and this is how they made a line in curved line in plan, and also curved line in section, and the students sitting around are making the sketches. So these people are alternately sitting down and standing, sitting down and standing. So and then alternatively the students are making the sketches. So these are the kind of lines, or you can have a curved line, or you can have a circular line, and all these people are standing up, or a straight diagonal line, and so on. And then they created this maze using matchsticks and paper which is wrapped around these matchsticks. These are some more examples of the same exercise where they draw the lines, and then they use coordinated colors for the paper, and then they stick these papers to create a maze. So you can actually enter this maze, and you can follow the path, and you can enter this, and you can enter that, and you can come out, and so on. So that was the whole idea, to make a maze. This was a very interesting exercise of my childhood memories. This is a fun exercise. So aims and objectives are, the exercise is part of the orientation week, and the idea is to draw 6 drawings depicting the most memorable moments of your childhood before the age of 6. This is this is an age where kids are most innocent, and remembering these days brings back vivid memories of childhood. These drawings should depict activities of the students playing or dancing or studying or eating or similar activities. Process: the students are asked to cut out photo mount boards to make a six-sided box the size of 150 mm of 150 mm. The students draw minimum 9 drawings and select 6 drawings of coloring. Make a mount board cube, stick these drawings onto the cube. The conclusion: the students enjoy this process of going down the memory lane and depicting these movements in drawings, and they are happy with their own creativity. During the jury, they are delighted to share these movements with the teachers. All these colorful memory boxes are displayed in the exhibition during the college festival. So this is, I'm just showing you one of the box. So he created going to the circles, and then annual day festival, and celebrating birthday. So I insisted that I want to see you in the picture. I don't want to see only bat and ball. I want to see you playing that bat and ball. This was a fun exercise again, where we asked them to make paper clothes out of newspapers. So we got a thappi of newspapers from the college library, and we asked the students to cut it and make a jacket, or a dress, or look at the cap that she is wearing, and he is wearing another cap. And then all the students paraded. So we had a fashion parade in the class with these paper clothes. This was an exercise which is called lines within the box. So the aims and objectives: the aim of this exercise is to develop the idea of abstraction and transformation, and increasing three-dimensional visual skills through sketching by drawing using soft pencils, ink and brush, and making models. The students spread out papers, draw and paint lines using ink and brush. These lines are then represented in three-dimensional hollow frame. They make a cube of 30 centimeter by 30 centimeter 30 centimeter using 2.5 centimeter strips of colored mount board. After this stage, the students may use harmonious colored papers to represent the drawings of the lines within the three-dimensional hollow cube. The students develop a minimum of 10 drawings and select one of the drawings to create a three-dimensional composition within the framed cube to transform these lines. Conclusion: this is a successful exercise in terms of understanding the strength of the line, patterns created by these lines, and how the same line looks transformed when the third dimension is added to the lines. The students experiment with spirals, waves, straight lines, curved lines. They are often astonished by the results when all these cubes are exhibited during the college festival. The guiding principle of this exercise uh, are distributing lines across the cube from all the sides to take care of density and gradations in line thickness and color harmony. So this is the top view of the cube, and this is how the cube looks from the side. So these are the lines, curved lines going from one corner to another. This is another example of lines traversing, and then this is the top view of that same cube. So we asked them to make a cube out of a mound board, and all these are colored papers. These are the way that the students had displayed these models during the exhibition. This is the exercise called three-dimensional visualization of lines, aims and objectives. The aim of this exercise is to develop hand and eye coordination, increase command over freehand drawing, using different mediums such as pencils, pens, ink, brush, etc., and to develop visual skills, and transforming these lines in the third dimension. The students draw or paint lines using close to each other using a flat brush, 6 mm thick brush dipped in black or blue ink. The lines need to be parallel to each other, and the distance between the two lines should be equal to the thickness of the brushed lines. The figure and ground should have the same weight. They make several drawings, select one, and visualize these lines in the third dimension and draw sketches of the same. The students make a minimum 3 drawings that are shortlisted for visualization in three-dimensional space. One of the drawings is used to make a model to transform these lines. After completion of the model, the window is created in a small piece of cardboard to look at the model from this window. This view is then drawn on paper. Conclusion: this is a simple exercise and students enjoy exploring the possibilities of creating three-dimensional transformation of their chosen lines. One such example is shown here. Very simple example of lines where he's using the brush, a flat brush, where he tries to keep the distance between the line and the white space same. And this is the model he makes using thermocol. So wherever you have a dark space, a dark line, and then it tapers down, so you have these lines which are tapering down. It's one of the beautiful model, and this boy was very talented. And when he brought the model, he brought it in a wooden box. I said, wow, this is something. So ये तो सुतार का बच्चा था. So naturally he was so skilled and he was so good with his drawings and with his workmanship. It was a pleasure teaching this boy. This is the window that he had created and made a drawing and shaded this drawing. This was a very interesting exercise. This is based on Charles Ames' House of Card project. So this exercise takes inspiration from Charles Ames' House of Cards project. There are 3 aspects to this project. The first is to learn control over brush strokes. The second is to understand color saturation, tones and hues, and the third is to understand interlocking and creation of three-dimensional compositions. Colors are chosen by the faculty members in such a way as to create a color wheel. So when all the cards are displayed on the ground collectively, one can observe all the shades and tints. The students are provided with 6 cards, photo mount board, laser cut to 7.5 centimeter into 15 centimeter in size with grooves. Students are instructed to draw orthogonal, diagonal, checkered or curved lines using a flat brush dipped in color assigned to them on 5 cards. They are given the freedom to add white or black to the original shade. The pattern on the 6th card can be of their own choice. Deliverables. The students are told to paint one surface with plain color and lines on the other side. The only constraint given is that space between the 2 lines should be equal to the thickness of the brush. Conclusion. This is a successful exercise in terms of understanding line work, color and composition of these cards in 3-dimensional space. So these are the cards when they are displayed on the ground, we spread them out, and so they are all beautifully colored and with the gradations of colors, as you can see. And these are the compositions. These are the various compositions that the students made. It's a fantastic project. They made compositions using contrasting colors, and then they displayed these cards, and another composition, another composition. This is a beautiful composition again. Okay, so then this is an exercise which is a theoretical work where you're talking about basic design elements around us. So aims and objectives. The image matrix on the next page is given only as a trigger point for further inquiry for the imagination of the students and the faculty members. First year is a period to develop minute observations and representation using various mediums. On the next page, we have given different images of basic design elements found in nature, arts and crafts, industrial design, art forms, and built form. Using a similar matrix, one can develop a number of projects which are outlined here. These projects are quite simple to execute, but but have profound collective impact on the students' minds. When these projects are displayed and discussed simultaneously, they generate many points of deliberations. Conclusions. This is the last stage of the process and very important step here. In this digital era, it is easy and simple to document, store, and retrieve this data at a future date. And retrieve this data at a future date. Documentation is of two kinds, one for the students and another for the faculty members. So this is the matrix where we have nature, crafts, um, and then industrial design, arts and build form, art forms and build forms, and then we have colors and voids and surfaces and lines and points. So points in nature, points in crafts, points in industrial design, and then you have colors in build form and colors in art form, etc. So here I have chosen these are all from nature. This is all the macrame work that I have done so far. This is the industrial products of the chairs. These are all the paintings and the sculptures by Piraji Sagara, and this is a beautiful bungalow designed by my friend, very famous architect Nitin Kilawala. So you can see the point, you can see the lines, surfaces, solids, and colors. So you can talk about the same thing, matrix of basic design explorations, principles, and art forms. So we have drama, dance, painting, sculpture, and cinema. And we have contrast, centers, balance, rhythm, and repetition. So repetition found in music, repetition found in cinema, and so on. So you collect these images and you stick them onto the black mount board and create a matrix. Experiencing space. Aim and objective. This exercise includes 4 rods of 2100 mm length and 4 long curtains of 4.2 meters by 2.1 meter in size in the modules of 1.5. So the curtains are tied to the rods to create a mock-up room. The process, one can start with this very small room of 1.05 by 1.05, and then we go right up to 4.2 by 4.2. The students start with creating the smallest room and use newspapers to create furniture layouts, and one by one they experience this space from within. Then the next set of students make a larger room and then they experience the space from within. The point is to find out how much space is required for each activity. This process of making a room, making furniture alternatives continues till they get to the largest room, which is 4.2 by 4.2. Experiencing space. The students are divided in many groups. Some create the rooms, some make furniture, and some draw these layouts in the sketchbooks. These activities are taken up in rotation. Based on these dimensions, students design 5 houses as part of the submission. Students participate very enthusiastically in this activity and they feel truly inspired by this 3-dimensional space created in front of their eyes. So this is the model that I have done. These are the spaces which I think I showed yesterday. Now this is an exercise about solids and voids. The project designed and this is a project designed and developed by me. In this project, I have taken a perfect 10 by 10 by 10 units cuboid space and extracted perfect cubes from within. I looked at the cube from all the four sides. This was a fascinating project for me, and working with layers was the key to this project. The views show the entire process of construction in layers, starting from layer 1, 2, 3, and then adding subsequent layers in every image. The idea was to subtract perfect cubes from four sides, either 1 by 1 by 1 or 2 by 2 by 2 or 3 by 3 by 3 units or 4 by 4 units. Plus there was a void of 2 by 2 units going through the entire cube. When I started thinking about this project, I decided to place many constraints on myself. I wanted penetration from all the sides, connections between the voids, and repetition of similar voids. Balancing the solids and voids was the main idea behind this exercise. Maybe this was a space for ants to live in and travel from one place to another, or maybe it was big enough to accommodate small creatures. They could crawl inside the cube and enjoy this space. I started with a unit of 1.2 meter by 1.2 meter by 1.2 meter, and then the entire cube could be 12 meter by 12 meter by 12 meter. The smallest space for sitting could be 1.2 by 1.2 by 1.2. Working space could be 2.4 by 2.4 by 2.4, and or it could be 3.6 by 3.6 or 4.8, etc. So these are the first three layers. I cut out one by one by one. This is going to be 2 by 2 by 2, 1 by 1, 1 by 1. Then this is a 2 by 2 cube, void taken out. And then these are more layers. This is the top view, and this is how the entire cube looks from one side, and the other cube looks from other side. Playing with a dice. So project designed and developed by the author. This was another exploration of space and creation of windows and bridges within the cube. The dice has a very interesting system of numbering on its 6 sides, where the numbers on the opposite sides add up to 7. The idea was to create voids for numbers on the outer surface and tunnels and bridges inside the cube. Notice the numbers carefully. One can see that the center position of number 1, 5 and 3 is the same. One can create a bridge from inside for connections. Also notice that the corner position of the numbers of 4, 5 and 6 are the same. For numbers 3, the corner matches the position of 4 and the center matches with 1 and 5. For number 2, the alignment is in the center. Actually, there could be connections from outside the cube and inside the cube. These bridges will create very interesting patterns for this cube. So this is how the dice looks, which is opened up. So you want to have 6 on one side and opposite is 1. You want to have 5 and 2 and 3 and 4. And this is how the cube looks. So you can create the bridges, connections inside, or you can have the bridges outside. Exhibition space for visually impaired. The idea was to create a composition of dots and lines, planes and surfaces, and extrude these lines to create three-dimensional space. The students create compositions using straight lines, curved lines, dotted lines, circles, and right-angled triangles. The next stage is to extrude these lines to create floor levels, walls, columns, etc., to create spaces and a pathway for people to move around. The aim is to create exhibition space for the visually impaired who would be walking barefoot while experiencing textures on the wall and on the floors. Deliverables. Create at least 6 compositions using harmonious color schemes. Extrude the lines to create space. Make a process model and then the final model. This exercise starts with a little enthusiasm due to the ambiguity of creating exhibition spaces for the visually impaired people. and for experiencing textures. Only after the parameters in terms of number of curved lines and straight lines and dotted lines and circles are given do the students grasp the project. Creating compositions and extruding these lines is a major step to crack this project. So this is one of the project. This was the composition, and this is the project that he created. For using these dotted lines, he used these matchsticks, and for this thin line, he used a very thin line, and then he cut this line so to create levels, and then he used columns here, and it was very creative and very nicely done. Carving out cube and adding two cubes. This is an exercise in creating space by carving out from one cube and constructing the other two cubes from two sides. This exercise is almost like a 3D jigsaw puzzle. The students are asked to imagine carving out spaces from the cube and draw isometric views of the cube and make a model. The next stage is in the stage includes addition of only frames of two more cubes and construction of planes within these cubes. Create an isometric drawing of a cube which is carved out using a grid of 6 mm by 6 mm. Construct a model using these layers. Then add two additional frames and place them next to the original cube. Draw an isometric view of all the three cubes. Draw the entire three-dimensional composition in isometric view and draw all the 12 floor plans. This is a long drawn exercise which is taken up at the end of the second semester. The students gain a lot in terms of understanding and visualizing three-dimensional space. So this was the original cube, then addition to this, and then addition to this, and then he extruded number of things. So this is a drawing, and this is the model, and this is the model, the top view of the model. Playing inside the cube. Aim and objective. The aim is to create a play spaces for small children within the cube. This cube could be placed inside the mall where the children can play under supervision and parents can do the shopping. The students are asked to study children, the way in which they play and run around. The students are given a cube. The size of the cube is 4.5 by 4.5 by 4.5, and then they make a scale model. The next stage is to design spaces at different levels within the cube. Where the kids can hide inside, hide and seek, or play in a jungle gym, or just run around. Deliverables. Create three-dimensional compositions for overlooking and overlapping spaces. Make small models including one process model and one final model. Draw plans, elevations and sections using colored papers. This is a long drawn project. Initially, there is a need to discuss in great detail, and the faculty members made a small little model and show them how this works. The students will grasp it easily. This is an aha moment for students. Then the results are stunning and quite varied. So this is one of the model where she had a diagonal. So this is also the plan and also the elevation, and this is how it looks. So you have one space here and another space here, and she has created the staircases, and people can run around and up and down. This also a place for running up and down. This boy was very talented. He created this staircase going up, and then one more staircase to go up, and then he created this model. He created a wall, and he created the staircases, and he created number of layered drawings on tracing paper, and he was so talented. He would flip one drawing to show us what is happening below. Very talented boy. This is one of the model. This is the same model. You have this wall on one side, and you have these platforms, and you can go up and you can climb that. This is another same project, another model. She was also very talented, and ultimately she also made illustration for my book. And so this she stuck all these papers to make elevations. And that's very interesting. Interplay of solids and voids. The aim of the objective aim is to create interplay between solids and voids, and there are two ways of creating spaces: constructing and carving. Students are given a cube of 25 centimeter by 25 centimeter by 25 centimeter. They divide this cube in half, either horizontally, vertically, or diagonally. Half the cube is carved out and the other half is constructed. And then they need to match the lines in planes, in plans and sections, and overall vocabulary has to be maintained. However, when one carves out, volumes are extracted, and while as when you start constructing, you add the horizontal and vertical planes are added. So the deliverables, the students are asked to draw 6 isometric views so that they can examine the cube from all the angles. They make progressive models using harmonious contours, colors of the facade, and for the inner voids. This is a great exercise to understand interplay of solids and voids. And on the day of the jury, when the models are displayed, the students are stunned by their own creativity, and the entire atmosphere is filled with great energy. So these are the models where you can see the horizontal cut, and these are all the voids, and these are the columns which are added, where again you can see the voids which are extracted. You can also, this is a vertical cut, this is also a horizontal cut. You can see a clear cut horizontal cut here, and you can see a vertical cut here. You can see the vertical cut, you can see the horizontal cut, and he used beautiful colors, one for what is constructed and one inside the cube. This was a very bold attempt. He cut this diagonally, and then he added the planes, added these lines to not to lose the essence of the cube. So essence of the cube remains the same. At the same time, you have this diagonal, which is very bold. Aim and objective. The project aims to understand the intricacies, steps and ramps, the intricacies of designing staircases, ramps, spirals, and mid landings. The idea is to create spaces using everyday elements that we negotiate for going up and down. The students are provided with 5 horizontal and 5 vertical grids, a 1.5 meter additional 0.3 grid is given in between these grids, and on all the 4 sides a structural grid. They are expected to create stairs, steps, ramps, and pause points at landings. Excuse me. So they are expected to create staircases, ramps, steps, pause points as landing. They work on the plans and sections and go on to make several models. Because it's structural grid, they understand the use of columns, walls, and despite of having rigid parameters, the students explore various possibilities. Deliverables: create plans and sections at various levels, taking care of the headroom. Develop a model using mount board only in black and white colors as the final deliverable. Conclusion: this is a successful exercise in terms of understanding levels, overlooking spaces, landings, and the ratio of trade and riser. The ultimate results are quite thoughtful and stunning. So, this is what the student did. So, they used this grid, and then they created the columns, and then they created the landing spaces and the steps. Look at this boy. Look at the way he created this entire spiral staircase, and then this. So the results were absolutely stunning. Another example. And they created such beautiful structures because they understood the structural system. Because we had given them that zero point 0.3 grid. So this is 1.2 and this is 0.3 grid. So they understood that yes, we are supposed to use this grid to give a support to the staircase, and because we had asked them to make only black and white, that also helps to create that stunning environment in the classroom. So this boy created jalis. He's again the same staircase with the grids, and he used these vertical walls. Very nice. Superb examples. Okay, so this is the mathematical derivation of golden ratio. So this goes on to explain Corbusier's theory of modular and golden ratio. This is a mathematical derivation. This is how it works. You take a square, you cut it into half, you draw the diagonal and drop the diagonal on this. What you get is the golden ratio. So what you get is 0.618. So I have created this entire grid using modular system. Indian modular. I created this Indian modular. I modified Corbusier's modular because Corbusier's modular man was 1.86. I modified that and I said that Indian average male height would be 1.7. So I derived the entire grid based on that, and I assumed the male height, average Indian male height as 5 feet 8 inches, and so on. And these are the various rooms that I created using single series and double series. I'm not going into the details because it's a very detailed explanation of the modular system. So people who are interested, they can always contact me and I can talk to them. This is the Indian modular system that I have derived. This is the modular man I created in macrame. As you know that I make these macrame wall hangings. So this is 1.7. Okay, and when the man raises his hand, it reaches 2.1. So half of 2.1 is 1050, and golden of that is 1700. And I have throughout my life, for making furniture, making architectural drawings, making architectural spaces, windows, doors, I have used all these dimensions while designing these spaces. Room of my own. Uh, so this is a very famous pattern from pattern language, room of my own. So the drawing on the right shows the interesting space which can be termed as a room of your own with the dimension of 2.1 by 2.1 by 2.1. This space can accommodate a bed, a writing table, a small shelf. This kind of dream space where one is surrounded by one's own things, music, laptop, books, a window to look out from, uh, a room with a privacy. Another option of the small space could be 2.1 by 2.75 or 2.75 by 2.75. When I was studying in Ahmedabad, the School of Architecture, Ahmedabad, I had a similar room which had my drafting table sitting on my table and a spool cassette player, and I used to play My Fair Lady songs while working. My bed was parallel to the window, and I used to sit on the bed reading a book and sometimes looking out. So this is the room. This is my drafting table. This is my bed. This is one of the shelf, and this is how it looks. This is one of the room. It's composition of solids, sliding coins. So this project is designed by me. I have many a times I used golden ratio to design the project. So this is a project of sliding coins. So I start with a grid, then I add the circles, I decide the axis, and I start shading these coins. Similar example. Composition of circles and diagonals. So this is the composition of 11 units by 11 units, and the grid is symmetrical along the diagonal axis. So as you can see that these are the grids, and and the various compositions using the same. And this is another composition using the same in black, white, and red. This is a black, white, and red composition. Creating spaces using golden ratio. So I have used this golden ratio to create spaces. So I created a composition using, so one by one are the corridors. So actually they are 2.1 meter by 2.1 meter. Then you have 2 by 2, 2 by 2, 2 by 2, and then you have 3 by 3, and then you have voids. So sometimes there is a solid room, sometimes there are very low corridors, and sometimes there are courtyards. So you can use these dimensions to create compositions. Enclosed and semi-enclosed spaces. So I created this composition using again the golden ratio, where you enter here, where you enter here. This is a small little space. This is another small. You climb down here, you climb up here. This is one exhibition space. This is another, maybe a library, and maybe a meeting place for where people can sit around and discuss. This is how it looks from the top. Experiencing space using golden ratio. So this was the project which was done by the students. So we gave them the dimensions of golden ratio, and we had recently visited Bharat Bhavan Bhopal, and so they used lots of ramps and lots of steps going up and down. We had given them a sloping site, and these are all the models. The students really explored the spaces, and when we gave them the projects, we had very specifically we said that we want to have enclosed spaces, we want to have open to sky, we want to have a semi basement spaces, enclosed, semi enclosed, covered, semi covered. So we had specifically said that we want to have all these qualities of spaces. Now this is an exercise. uh, Sorry. So where in this exercise we explore the understanding of sunken and raised base plates, and use the steps as to navigate. I'm sorry, there are lots of spelling mistakes here. And so we created these spaces. So what we did was, we had given them number of plates and number of horizontal surfaces. So you climb up, and again we had restricted them to use black, white, and red, and they created these beautiful spaces. So these are number of models put together and taken a photograph. This is a close look at fruits and vegetable. So we had asked them to to get a fruit from their house, and they would. The idea is to look at nature very minutely, as if under microscopic eye. And the first step is to draw the selected fruit from outside. Second step is to cut it across and take a cross section. They study the patterns and the colors, and they draw it. This is a beautiful example of a walnut, pomegranate, onion, pomegranate a walnut from inside. This is an enlarged rose. Study of elements from fruit and vegetables. So this exercise aims at developing a keen observation and the power of presentation. So fruit, vegetables, and leaves are selected. The next objective is to do the abstraction. So there is a very famous, very famous artist, and he has written number of children's books. His name is Eric Carle, and if you just type his name and go on to understand the techniques that he has used wonderful techniques to create collage, and this technique was introduced to the students, and then they drew the fruit, and then they extracted, and they drew it, and then they did enlarge it, and then they did the abstraction of this fruit. This is the man I'm talking about, a very hungry caterpillar, and these are the drawings that he has done. This entire book is just fascinating. So I taught that technique to the students, and these are the parts of the, and then they created these tracing papers with colored papers, and using those papers he created his composition. Look at the composition of papers. Inspiration from of lines to make the structures. So we say that, okay, you look at the grids from the nature, and you take inspiration to make structures. So this girl took impression of the thumb, and she took inspiration from the thumb lines, and she drew the lines, and she created an amphitheater. This boy took inspiration from the lines of pineapple. He drew the lines, and he created this small a pavilion. He created a small pavilion. Look at the lines. She created this beautiful window space using abstraction from the fruit. This is a designing interface between water and land. So our college was located right next to the Carter Road, uh, the sea and the Carter Road. So this is the interface between. So they created a garden between the Carter Road and the sea. I like the fact that this boy used the frames, and he created these frames. It's a wonderful exploration. Again, there is a matrix here which talks about a matrix for understanding natural flora. So you have trees and branches and leaves and flowers and fruits, whereas on the other side you have the principles like repetition, rhythm, balance, centers, and contrast. This is a beautiful picture from nature. This is another beautiful picture from industrial art. So create a book on terror attack. So we had recently we had an attack in Mumbai. So I asked the students to create a book, and then they created this project. The size of the book was 20 centimeter, and they created 16-page storybook. This is another storybook, and this girl was very talented. Designing and making furniture or storage units. So this boy was so amazing. He created this folding table. Look at the way the detailing he has done. That this thing really flaps down, and this thing goes inside. He created these tools which are telescoping. He created a bench using straws. He created this such a beautiful furniture piece. He created storage units. So this was another activity that we had done, buying and selling activity. I think yesterday I had shown this project. So these are some of the explorations. This is a collage based on fantasy books. So we asked the students to read Alice in Wonderland, and we introduced this book to the students. They read it and picked up one scene from the book, which they visualize through the sketches, and then they drew the images from the magazines. They took images from the magazines, and then they made a collage. So this is one such exercise of taking inspiration from Picasso. So they selected Picasso painting, and then they extruded the painting into a three-dimensional space. This is another exploration of Picasso. Yeah. So this is Alice in Wonderland. So this is Alice in Wonderland, who she's completely sort of baffled. She doesn't know which way to go. Exploring children's dream world. So we gave them a book of Wizard of Oz to read, and then they created number of small models. So this was the Wizard of Oz. This was the shoe. This is a beautiful collage exploring contemporary art. So here we asked the students to study the paintings by S.H. Raza, his Bindu paintings, and we asked them to extrude it. So these are all the extrusions. You go into the basement of this. I mean, you are going inside like a kund. Can you see? It's like a kund. And we ask them not to change the colors, keep the same colors as the painting. This is from one of my students made this model especially for the book. So this photograph is from the book. And look at the colored model. So I asked him to take a photograph of without before coloring and then after coloring. Yeah. Yeah, so that was a so yeah, now I'm ready to take the questions. Hi Ritu, unmute
Hello,
yourself.
ma'am. Yes, wonderful presentation.
Thank you.
And you have
Comments?
always been an inspiring person. Basic design, you do a lot of good creative exercises. And I have had a first-hand experience of that.
Yeah, thank you.
Hello?
Yes.
Hello? Can you hear me, ma'am?
Yeah. Who is this? Yes, Shanik, you want to say?
Hi, ma'am.
Yes, hi.
As usual, it's a wonderful session again. It's really showing how can we bring better architect for the future. Each and every design brief is like from the first year itself, we are molding students in a way that we can create a better architect for the future. How can we make them socially responsible through such a project like exhibition space for visually impaired? At the same time we are providing them to a way to explore their potential. So at the same time they're making them so we may not be considered the people like visually impaired or physically challenged. So the each and every design brief are considering, and some works related to terrorist attack, so make them aware of this. All things are happening around us, and we should be responsible for the future. And we have the right to do something for the better future. It's really great,
Yeah.
ma'am. And at the same time, um, uh, through your presentation, it's very evident that we have to be like playing with the 3D models will help them to made an understanding in more about the volume, form, space, and order, which also will make it very good and for the future semesters and also. Yeah, thank you, ma'am. Thank you so much for the
Most
informations.
welcome. You're most welcome. Most welcome. Yeah. Anybody else? Divya, you want to say something? Yes,
Yes,
Divya.
ma'am. Such a wonderful presentation you have done. It is such an enlightenment to see all the exercises which I have never thought of, and you have culminated n number of exercises for first year students. Very thank you so much ma'am, for your presentation.
Yeah, these exercises are part of the book.
Yes, ma'am.
So you can see that. You can see they're all
Definitely.
part of the book. Yeah.
Thank you.
Yes. Anyone else?
Anyone else wants to share anything or have any questions to ma'am?
I want more reactions. Yes, Ritu. So what do you mean by elaborate interpreting paintings? So what we had done was we told them that okay, you take these as your floor plan. So once you take the Picasso painting itself is abstract, or Raza painting is already an abstraction, and then you are extruding. Then you are trying to sort of extrude these elements. You are trying to negate certain lines. You are trying to increase the density, and you are creating spaces. So it was an exhibition space. What we had done in Picasso painting, it was a Anand Mela, and they wanted and we wanted them to extrude these spaces so that one can travel inside, one can see, or you can create an amphitheater or create a space for. So it was an experiencing space. Basically, what you're doing, you're experiencing space. That was the idea.
Thank you, ma'am. Yes. Thank you for the elaboration.
Yeah.
There is also a question by Mansha Samreen, ma'am. Ma'am, can you please unmute yourself and ask this question yourself to ma'am?
Hi, ma'am. Can you hear me? Am
Hi.
I audible?
Yes, I can. Yes. I can't
Yes.
see you. Start your
Ma'am,
camera.
actually, there's some issue with my camera. So,
Okay.
yeah.
All right.
Yeah.
Tell
Ma'am,
me.
your all the exercise that you have discussed are really great, and I feel it will tingle the brains of all the first year students. What I wanted to ask you that how much time do we give to have all these exercises
Yeah.
in the
So
class?
yeah. So what normally I do is theoretical exercises. Sometimes are given as a group exercise, and the studio exercises are given as an individual exercise. So it takes about 2 months or so. So in the entire year we might do 2 to 3 projects, and then number of theoretical projects. So it's not as if that we are doing 50 different projects. No, we do very few projects. All the projects that I've shown you are over the years. It's not one year. They're over the years we have conducted, and I have documented these projects. So it takes at least 2 months. I mean, initial stages, understanding, then making a preliminary model, then discussing all that, and then the final model, and then the final jury. So it takes 2 to 3 months, definitely, because the
Okay.
one
Thank you,
semester
ma'am.
is about 4 months. Yeah,
Right,
yeah.
right. Because ma'am, that painting one, na, similar exercises I also did in my first year design studio, with a group of 4 to 5 students in each group, and it took us around 1.5 months to get going. So I just wanted to check on that. So is our timeline okay with
Yes,
everybody? Yeah. Okay.
yes,
Thank you, ma'am.
yes,
Thank you so
absolutely.
much.
Thank you for that question. Actually, it is such a valid and practical question because when we give such exercises to students, different students also take different amount of time to process it. Then in the semester, we have our own deadlines, we have midterms, exams, submissions, marking. So to work on the creative process along with that formal procedure that the university goes on with, that is also a very big challenge for all faculties. So yeah, that
Yeah,
was a very good question.
yeah. Yes, Divya, you can unmute yourself.
Yes, ma'am. I was saying कि you said 2 to 3 studio project and remaining is theoretical project. Ma'am, what
Yeah,
theoretical?
so
So
theoretical
that
projects are the metrics that I showed you.
okay,
It's a
okay,
theoretical project.
okay,
Then reading a book is a
okay,
theoretical project. Making a timeline is a theoretical project. So there are a number of theoretical projects that we take up.
okay,
Analysis of a building, build form is a theoretical project. So there are a number of theoretical projects that we take up in first year.
okay,
And then the studio project. So we have divided basic design into two parts. One is a theory and one is a the studio. So studio is a long drawn individual project, whereas theory is combined 3 to 4 students together, and then they make one project. It could be just
okay,
1 week or so. Theoretical project is just 1 week.
okay. Thank you.
Ma'am, I just wanted to ask one small thing. Can you also recommend some books that we can share with first year students for reading?
I mean, first year तो चिंग की बुक है ना, फॉर्म स्पेस एंड ऑर्डर. इट्स अ
Yes.
ब्यूटिफुल बुक. It's a beautiful book. You can share that.
Rakesh sir, I can see that you have also written a question in the chat. Can you please unmute and ask the question yourself to ma'am?
So hi ma'am, this is Rakesh from BMS School of Architecture. I'm an
Hi.
assistant professor. So
Yeah.
the ones which you had actually shown with the pergolas and that golden ratios exercise, I just remembered what I had done in my architecture days. Like the project which was given was walk with the walls. So
Uh-huh.
you actually had to create certain important spaces with the hierarchies of placing a different sculpture to give a different imagination to the student. So that was the exercise, and probably if you can elaborate on that particular aspect. So I mean that particular project, what you had given to the students, it would be helpful for me to incorporate for my students in the college as well.
I think I'll go back to that slide. You want me to go back to the slides?
Yes, ma'am.
Yes. So I'll read this. So what had happened was we had gone to Bhopal, as I said, and Madhya Pradesh, and the exercise aims to develop design ability for space planning with a thrust of creating linkages between basic design and architectural design. The project brief is to design an exhibition space for artworks. This particular year, we had taken the study tour to Madhya Pradesh and we went to Bhopal. We visited Bhopal Bhavan, Bharat Bhavan, designed by Charles Korea. The project takes inspiration from this project. Case studies are carried out and book studies are planned out at the start of the project. A site of 21 meter by 21 meter is assigned. The students are asked to design compositions using golden ratio and articulate various kinds of spaces: enclosed, semi-enclosed, covered, semi-covered, and open to sky. Deliverables. Each student needs to make at least 6 different compositions using orthogonal geometry. Out of these, one composition is selected to develop floor levels and add walls and structures, structural system, create plazas, courtyard, steps, ramps, and staircases, blocks. A preliminary model and then a final model is made. The conclusion that this is a successful exercise in terms of students' enthusiasm, passion, and input. So I forgot to tell you that this was a sloping site. So we had given a sloping site that you start at a higher level, you enter at a higher level, exactly like Bharat Bhavan, and then you step down. And then they created lots of various kinds of spaces, and uh, balancing between solids and voids, covered and semi-covered spaces was very important. For example, we did. So this particular boy, he was so good. He was so good. Look at the kind of intricacies that he has developed. Even this is so beautifully done. So so that is how we had done. Does it answer your question, Rakesh?
Uh, yeah, I was just very curious to know because it was all relating to my own architecture days. So it
Yeah,
was nice to see this
yeah.
in this presentation. Ma'am, is it possible if you can share the presentation?
No, you can. All these are part of the book, so you can get the book.
Uh, okay.
Yeah.
Can you please tell me which book is it, ma'am?
This is called Learning Basic Design.
Okay.
Yeah, and I'm giving 10% discount.
Okay,
So
ma'am.
you can contact me. I think Nishtha is going to share my phone number,
Sure,
and you
sure.
can contact me, and I can you give me your address, and I can send the book to you.
Sure, sure. Right.
Yeah.
Thank you.
Should we share the presentation, the questionnaire, the exercises, Nishtha?
Sure, ma'am. Ma'am, people also have some doubts related to, yes, more, a
Yeah.
lot of people are asking that what are the assignment topics. Some people are also asking that if they can do this in a group of two or they need to do the assignments
I don't
individually.
mind. I don't mind. I have no problems.
Okay.
They can do it in two or three. Yeah.
Oh, yes, ma'am. We can share the assignment topics with all the participants now.
Yeah. So let's go through the assignment. Will you share that,
Sure,
or
ma'am.
should I?
I'll share the screen, ma'am.
Yeah.
Just give me a moment.
And
Uh,
let them go. I will go through that the exercises, and then by tonight they should be able to finalize, and they should be able to give you that who is doing what.
Okay. Sure, ma'am.
So how many participants are there? You said.
Ma'am, right now in the class there are 39 participants,
Yeah. Yeah.
but
That's
we have total 45 registrations.
okay.
I'll share the assignment with everyone.
All right. Yeah. So should I start? Enlarge it, no?
Yes, ma'am. Is it visible?
Yeah. Go back one.
Yeah.
Yeah. So this is something which I have done. This exercise which I have done. So I took this mount. No, I'm sorry. I'm sorry. This is not done by me. This is actually done by the professional. But I had done models using file card, exactly the same kind of model. But this particular model is done by the professional. So I got it done in the. But you can do this using make blocks 3 centimeter by 3 centimeter 3 centimeters, make 12 such blocks, 6 by 6 by 6 make 3 numbers, and 9 by 9 by 9 make one number. And some will be with you can use photo mount board. Why I'm saying photo mount board is because it cuts beautifully the and you can cut out the blocks very nicely. So sometimes you have a block with 4 sides, sometimes with windows, sometimes with jali, as shown in the photograph. So this is one assignment. Next. Okay, why I'm showing this is also so that you can ask your students to make these exercises. So that's the whole idea. So my memories of my childhood: draw 12 scenes from your life: happy, sad, hilarious, brother, sister, your mother, your father, your school friends, your sports, your studying, reading. So make 12 drawings. Next. And stick this calendar. I already made the calendar, so you just have to print it and cut it and stick it on that, and make a box, make a stand so that you can put this and make a cutout of mound board and stick these drawings and stick this calendar on that, and you can make 12 drawings, and you can make 12 pages of the calendar. Next. This is make a book of shapes. This is 15 centimeter by 15 centimeter beige color file card. So you cut out, you make 12 these squares. Then you cut out kite paper circles or squares or triangles or rectangles or oblongs and draw minimum 12 various expressions of a circle. For example, you can make a sun out of it, or make a fruit out of it, you can make a thali out of it. You decide what you want to make a composition to express textures, or make a abstract painting, and you create a book. So it's called create my book of shapes, or my book of circles, or my book of squares. So you decide what you want to do, and if 2 or 3 people are doing this together, you see to it that at least there is some harmony within the within the 3 people. So the book should look as if it is done as one project. Next, this is a storyboard. So with many illustrations and captions, draw images, write captions, start the story, body of the story, twist in the story, end of the story. The subject could be fantasy, science, fiction, fairy tale. It could be a life sketch of your grandmother, grandfather. It could be a day in the life of your mom, dad, sister, brother. You decide the topic, and you create this entire format, and you start writing and you start illustrating. So it's an illustrated comic format of a book, of a storyboard. It's a storyboard. It's not a book. It's a storyboard. Next, this is this is make a cube. This is again 15 centimeter by 15 centimeter by 15 centimeter cube. You decide what you want to draw. You can draw and paint a flower, make an abstraction of the flower, make a pattern for block printing, make an overall pattern, make a small sari pallu, make a sari border. You decide what you want to do with that, how you want to do the abstraction. You can overlap them, you can enlarge some, and you can do this as a cube project, and stick these drawings onto the cube and make a cube. Next, this is make a poster. Learn to pitch your ideas. This is called elevator pitch. Talk about your favorite subject. It could be you're promoting milk or fruit or flower, tree, season, city, village, country, collage, your own hands, your feet, your brain. I mean, you name it. I mean, you can talk about a cinema or a drama, song or a dance. This is a large drawing with a very bold caption. So you want to have a very large drawing. So I have given a size of about, say, 12 inches by 12 inches, and then you create a drawing, and then you write the caption. It can be even a collage. Yeah. Next, this is a matrix. This is a matrix of elements and our world. So images so this is again a matrix of 12 inches by 12 inches. You can print it out, and you print out pictures from the net. You find out points in nature from the net, you points in crafts, but select one craft. Don't select hajar crafts. Select, if you're selecting wooden work, okay, do everything in wood. If you're selecting industrial products, okay, if you're doing chairs, if you're doing curtains, industrial curtains, you can do so many things. You can do industrial bags, for example, or art forms. You select one artist, and then you find out points and surfaces and colors, etc. Or in the build form, you select one architect, and you find out all this in that, and create these windows, and stick those drawings, print them out and stick it. Or you can create this on the computer itself. I'm giving you a PowerPoint, so you can actually stick it and insert all these drawings within, and you can do that. Yeah. Next, Nisha, next. Yeah, so I am giving you four different alternatives of the same exercise. Create a matrix of matrix understanding natural flora, so trees and branches and leaves and flowers and fruits, and you have contrast, centers, balance, rhythm, repetition. Yeah, next. This is for the next exercise. Next. So these are six thinking hats. I have given you on the previous page. I have given you number of exercises, uh, and you can select six thinking hats, and then you can analyze this entire matrix, entire chart through that, and print out this chart. The chart printing of the chart could be either 8 inches by 8 inches. I don't mind. So the chart printing is 8 by 8. Everything can be 8 by 8. Even though poster can be 8 by 8. Yeah, it could be small. The This is mind mapping exercise. I have given you number of topics for mind mapping. You can select mind mapping, and you can do that. Next. And this is SWOT analysis. I have given you number of topics for SWOT analysis. You can select SWOT analysis, and you can do that. Nishtha, we are already getting number of requests.
Yes, ma'am, I can
Rakesh
see
is
that.
going to take, yeah. Monica Goyal is going to take number 6. Kirtika Mathur number exercise 7, 7A. Nitin 7A. Yeah, fine.
Okay, ma'am,
Yeah.
sure, we'll consider. Participants, I am going to share a spreadsheet. Once this session is over, you all are requested to please put your names in that spreadsheet for whatever assignments you want to take. This will also help us in maintaining a record of what assignments you are working on. And please make sure that you give your names before tonight. We want to have a final list of the assignments that everyone is doing by tonight. And you will have to bring these assignments in the last day of the FDP, last day, that is fifth day, 4th of August. In that day, ma'am will take another session in which she will evaluate all these assignments and give feedback on the same. So we will be discussing all these assignments in the lecture with everyone. So please make sure that you complete this assignment before 4th of August.
Yeah. Any questions? Any questions?
I have a question. What can be
Yes.
the mode of submission for these assignments once everyone has done?
You just show us if it's a cube. You bring it in your hand and you show it to us.
Okay.
Or if it is on the computer, then they show us what they have done.
Okay.
Any questions? The topic was for SWOT analysis. Divya, I have already noted down number of topics for SWOT analysis. As soon as you get this PowerPoint, you will see that.
I hope my screen is visible again. I'll just show you.
Yeah.
These are the different topics for various exercises. The first few topics are for SWOT analysis. You can see the title is written there. Then there are some topics for six thinking hats assignment, and there are some topics for mind mapping. So there are three exercises in which you require these topics, and these are listed topics for all three of them. So you can choose any of these topics and work on any of these three exercises. I hope it is clear for everyone. Aditi ma'am, yes, I'll personally add you in the WhatsApp group. Please don't worry. I'll add you there. Anyone else has any doubts or any questions?
How many people in one group? Not more than three. Either two or three. I have listed down so many things about mind mapping. Kritika,
Yes, ma'am,
Kritika, I
I've
have given.
seen. Yes, ma'am, I've
Yeah,
seen one of your students' work, but I could not like recall it. So,
that
just
was about
wanted to.
housing. You remember? It was
Uh,
about housing. You had the housing in the center, and then you said that okay, study of houses and study of build form,
yes,
and
yes,
study of
yes,
diagrams. Yeah. So
yes.
what you do is in the mind map, you write the topic in the center, and then you're branching out, and
Okay.
there is a main branch. There is a
Hmm.
main branch, and there are sub branches. So main
Okay.
branch has a red color, for example, one of the branches, and
Hmm.
so that everything in that branch will be red, or something
Okay.
else is in yellow, then everything in that branch will be yellow. So
Okay.
it is to be done on the computer, and you can download that image.
Hmm.
Nishtha will share this entire PowerPoint with you, so that you
Yes,
can
ma'am.
actually work on the computer itself
Okay, ma'am.
for
Okay,
mind
ma'am.
mapping.
Thank you, ma'am.
Yeah, yeah.
Any more questions, doubts, queries?
Clarifications, comments.
Even if there are no questions, we would love to hear from you. We would love to hear your feedback about this session or about the FDP. If there's anything that you wish to say, please, you can unmute yourselves and you can say. Okay, ma'am, can we wrap up? Or is there anything
Yes.
that is remaining to discuss?
No, I'm fine. Yeah, we'll wrap up today.
Okay, ma'am. I will share the presentation with each and everyone in the WhatsApp
Yeah,
group.
yeah.
And once the spreadsheet is ready with all the names, I'll also share the same with you, who
All
is
right.
doing what, and
All
then
right.
we can discuss the assignments on
Sure.
fourth in the last session.
That's right. That's
So
right.
yeah,
Yeah.
so I'll be sharing that
Thanks a lot.
spreadsheet with all of you. Please make sure that you put your names before tonight in the spreadsheet for assignments.
So, Nishtha,
Yes,
what
ma'am.
you do is, along with the PowerPoint itself, you share the spread, or
Okay.
the spread is only between you and me.
No, no, ma'am. I'll share it with the participants.
Huh.
They will put their names.
Huh.
Once the names are there with me, I will share the same with you.
That's right. That's right. Yeah. Thanks.
Okay.
Bye. Take care.
Ma'am, I would like to thank you before you leave. I would like to thank you once again for being with us and taking your time out for us through all these sessions, and all the exercises that you mentioned today they were so interesting and so eye-opening, I can say. All the exercises were very interesting, and most importantly, the students' work that had come out on the basis of the exercises that you had given. The students' work was also very beautiful. So it was so good to see that the students are also reciprocating to
Yeah.
what you all are teaching them. It was very beautiful to see, ma'am. It was very inspiring as well. Hope we all can also learn from these exercises and use them in our classes. And
Yeah.
I'm really hoping that good assignments will come from all the participants in this
Yeah.
FTP as
Yeah.
well.
I'm also hoping, and I'm also looking forward to the exercises.
Ma'am, there are some comments in the chat box also for you. People are
Yeah.
thanking
Yeah.
you and
Yeah.
talking about the
Aditi,
exercises.
Aditi, can you unmute yourself? Where are you? Aditi is not to be seen. Okay, all right. I mean, I like to see the faces rather than just reading the names. I like to see the faces. Ritu, you want to say something?
No, no, I don't know. I just wanted to show you my face.
Okay, you wanted to show the face. That's a great idea. Yeah, yeah, it's a pleasure. In fact, when I used to conduct these online classes, I there was one session where everybody's camera was on, and then the person who was taking the session would take a photograph. Yes, it, they're present, so that's how they would do that. So I think we should do that. All of you should start your camera.
Yes, it is a request. If you all can just put your cameras on, we will take a picture.
Yeah, you take a picture. It's nice to see. Nice to see. It's a good feeling, for the person who is conducting this. It's nice to see faces.
I think some people are yet to switch their cameras on.
Yeah, 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 yeah.
Everyone, please put your cameras on. We are taking a picture.
This will give you attendance.
We used to say the same things to students
I
while
know.
conducting online
Yeah,
classes.
yeah, I know. I know.
And I guess all of us, everyone is a teacher here. So we all say the same things to our students as well.
Yeah. Yeah, it's so nice to see all the faces. Good. All right. Thanks,
Okay.
Nishtha.
Thank you,
Bye.
ma'am. Have a good
Bye.
day, ma'am.
Yeah, thanks.
Thank you, ma'am. Take
Thank you,
care.
ma'am. Thank you so much.
Thank
Take
you.
care.
Thank you so much.
Thank you, ma'am.
Bye.
Thank you, ma'am.
Bye.
Thank
Bye.
you, ma'am.
Bye.
Thank you to
Bye
all
bye.
the participants as well. Thank you all for joining today. I'll be sharing the assignments and the spreadsheet with you. And we're really looking forward to some vibrant, beautiful, and colorful assignments from all of you. Please be back again tomorrow on time. Tomorrow also we will be having two sessions. First session will be taken by architect Abdul Alim Babu from Jamia Millia Islamia. He will be talking about healthcare architecture design. And the next lecture will be taken by Dr. Arindam Biswas from IIT Roorkee. He will be talking about urban regeneration and community inclusive design. We'll be sharing the update for tomorrow's lecture with you all. So please be available in the class in time. First lecture begins at 12:30. So I request you all to join the Zoom link by 12:30. Thank you all. Have a good day. If you have any doubts, please feel free to reach out in the WhatsApp group. Thank you so much. Thank you, ma'am.